Okay, so what we are going to do today is solve more logarithmic and exponential equations. And we're going to do that primarily with the exponent laws and logarithmic properties that we looked at last class. So just real quick, note that some of the sometimes we will have a logarithm or an exponential where it's all ready to solve, because if you look here, x is already by itself on one side of the equal sign. And so for us to do that, all that we have to do is alpha window 5, and then the base is 1/4 of 64. So x is -3. Gotta verify our answers. There we go. In this case, because there wasn't really anything to move around, all that we're doing is just making sure that that's in fact what we typed into the calculator, and it is. There we go. And if you don't have one of these calculators at home, that will do the alpha window thing, so you can type in a base. You can use change of base, which means that instead of all that, we would have typed in log of 64 divided by log of 1/4, which is still -3. Or we can also use Desmos. That's also an option. So same deal here, find 2 to the 5th, which is 32. And then just add 4. Two to the 5th is 32. 36 minus 4 is also 32. So 36 is our answer. Okay. Number 5 here is kind of interesting because we have our exponential part on the bottom of a fraction. So for one like this, we're just going to multiply both sides by 2x, or 2. To the x. Too close to the edge of the screen. Okay. There we go. Divide by 4. So 2 to the x equals 1/4. From here we can either convert it to a log. So one of our options is to do log base 2 of 1/4 equals x. And we can type that in and get -2. The other option, which we can do if we recognize 1/4 as 2 to the negative 2. If the bases are the same and they're set equal, that means the exponents are the same, so x equals negative 2. So either way, we can get it from there. Verify. Room. Okay. I'm just going to verify over here. So 4 equals 1/2 to the negative 2. Well, we know from the negative exponent rule that if we have something raised to a negative exponent, that we flip that fraction. So it becomes 2 squared, and 2 squared is 4. Therefore, x equals negative 2. Same basic rule here. $27 is the same thing as 3 cubed. 9 is the same thing as 3 squared. And we know from the power rule that we can multiply those two exponents together on the left. So 2 times 2x minus 5 equals 3. So 4x minus 10 equals 3, which means that x equals 13/4. Okay. 9 to the 2 times 13/4 minus 5 equals 27. Okay. 13/4 times 2 is 13/2, and I changed 5 to be 10/2 so that we have a common denominator. 13/2 minus 10/2 is 3/2, and 9 to the 3/2 is indeed 27. Which means that 13/4 is our answer. I'll do this one instead. Okay. Eight is the same thing as 2 cubed. One over 16 is the same thing as 2 to the negative 4th, because 2 times 2 is 4, times 2 is 8, times 2 is 16, so that's the 4. And then because it's 1 over 16, we make it negative so that the fraction will flip. And then this way we have the same base, so we can use the power rule to help us simplify our exponents here. So now that we have it like this, we are able to set our two exponents equal to each other since the bases are also equal. Okay. Add 4x to both sides. So that means that 10x equals 25. So x equals 5 halves. All right, so now we're going to verify our answer. So that's 8 to the 2 times 5 halves minus 3 equals 1 over 16, 6 to the 5 halves minus 4. 2 times 5 halves is 5, minus 3 is 2. And then 5 halves minus 8 halves. So 4 turns into negative 8 halves for a common denominator. 5 halves minus 8 halves is negative 3 halves. So 8 squared, I believe is what it was. Yeah, 8 squared is 64. And 1 over 16 to the negative 3 halves. Is also 64. So 64 equals 64. Which means that 5 halves is our final answer. Okay. The last kind of problem that we're going to look at today is one where we have to use logarithmic or exponential properties in order to simplify before we can solve. So if we look at number 2 here, we have on the left side 2 logs with the same base, and there's a plus in the middle. That is the product property. That tells us that the log with whatever base of xy is the same thing as the log of that base of x plus the log of that base of y. So that means on the left, this is the same thing as log base 3 of 8x Now we have two logs with the same base that are set equal to each other by the equality property. We know that the log of whatever base of something, when that's equal to the log of the same base of something else, that means that those two arguments are equal to each other. So since the log base 3 of 8x equals the log base 3 of x plus 2, that means that 8x equals x plus 2. So now we're going to solve for x. And we get 2 over 7. Okay, so now we're going to verify. We're definitely going to want to use a calculator for this because I don't know about y'all, but I don't know what log base 3 of 2 over 7 is in my head. So we're gonna plug this all in and figure out what this is. I'm gonna clear all that out. Okay, so alpha window 5 to get the log with that base. Arrow over to the right to get out of that space. Of alpha y equals 2 over 7 plus alpha window 3 of 8, and that's this lovely decimal here, equals. So now we're going to put in this one, log base 3 of, of 2 over 7. I didn't know I could do that. 2 over 7 plus 2. And we get the exact same decimal. So, okay, so it doesn't turn into a fraction. But regardless, 0.752 does indeed equal itself. So the answer is 2 over 7. Okay, here's another one like it. Remember that if there is no base given, that base is a 10. So all 3 of these logs here are base 10. We have that plus in the middle again, so we can multiply those together. 2 times x is 2x, plus 2 times 4 is 8. And since they have the same base and are set equal, we can set the arguments equal to each other. (10x minus 2x is 8x, and 8 divided by 8 is 1. We're going to verify. So we've got the log of 1 plus 4 plus the log of 2 equals the log of 10 times. Times 1. Okay. 1 plus 4 is 5. 10 times 1 is 10. So alpha window 5. Oh, actually. So we can do that and put the 10 in, but since it's base 10, we can actually just hit that button down there. Plus log of 2. And log of 10 is also 1. So 1 equals 1. That is indeed a true statement. And there we are. Over here on number 8, we are going to have to use some exponent law to help us. We have the quotient property. Which says that whatever our base is, it's the same thing as subtracting our two exponents. So over here, our base is x. We're going to subtract the two exponents. Excuse me. 5 minus 2 is 3, so x to the third is 729. Take the cube root of both sides, and we get that x equals 9. Okay. So 9, let's see, alpha. Okay. 9 to the 5th divided by 9 squared gets us 729. There we go. Okay. So that's all 3 types that we're going to see. So just simplifying it. Converting one of these exponential ones so that they have the same base, and then setting the two exponents equal to each other, or using logarithmic or exponential properties to simplify and solve.